All right, everybody. Welcome to Protips for Windows Azure Mobile Services. My name is Chris Reisner. I'll start by just telling you a little bit about myself, and then we'll kind of get into what we're going to talk about today. So I am a Windows Azure technical evangelist. I focus on mobile connectivity with Windows Azure. Primarily, I actually do a lot of iOS and Android development connected to Azure mobile services as well as some other stuff. But I also play around with some Windows Store and Windows Phone stuff as well. Prior to doing mobile development, I actually spent about 5 or 6 years doing a lot of C#, so ASP.NET, MVC, smart clients, all sorts of fun stuff. I've got my Twitter handle and my website up there. I grew up in Michigan. I currently live in Washington, so I do all the things that you're required to do in the Northwest, like hike and bike and all those fun things. Also there, I also co-organize the Seattle Google Developer Group. So who has already seen a session here or somewhere else that kind of went through the basic features of mobile service? Better yet, who has not seen a session that kind of went over the basic features of mobile services? All right, I see at least a few hands. So some of this stuff is not going to be as understandable to you because if you haven't played with it, you haven't messed around with some of the different stuff. But it will certainly still be helpful, and if you go play with mobile services and then watch this, it'll probably prove to be very helpful. A lot of the demos are going to be in different languages, and I'll show you some different apps, a lot of them iOS stuff. But remember that whatever I do show you today, it's kind of applicable to any of the platforms. And from a code perspective, if you're familiar with any kind of major language, it should be pretty trivial to kind of look and kind of understand, even if you don't get the syntax. So the first thing we're going to do is we're going to go through a recap of mobile services, so really quickly and on a high level talk about those features that mobile services provides, and then we'll obviously go into a bunch of tips and tricks, and we should have ample time for questions at the end, so we'll get to those then. So mobile services is a back end of the service, and the idea is that instead of you having to develop code, test, deploy, manage, etc., your back end, you just turn it on, and with minor configuration on your side, you're able to take advantage of all these great features that you really want in your mobile applications, or really in any application, but you don't have to do the work to get them. So with mobile services, you get stuff like structured data storage powered by SQL database, push notifications down to your native platforms, as well as a way to do push out to like WebSocket style stuff, user authentication and data authorization, server-side logic, so rich, powerful scripts that you can execute, whether whenever you connect to a table or independent of that. The ability to scale, so when you're testing or developing your application, maybe you only need to support 10 users, but once you launch on several platforms, maybe you need to support millions, and mobile services will give you that capability. Logging and diagnostics, and then back-end processing with scheduler. And if you haven't seen one before, go watch another session on mobile services, and it'll kind of walk you through how each of those features works with mobile services. So the first thing we'll mention is multi-platform apps. So I get this question a lot, and it's, some people just don't understand, but you don't need a different mobile service for each platform you work on. So if you build a Windows Store application and then you make, the same application for iOS or for Android or for the web, you don't need to spin up a different mobile service to connect those. You connect all those platforms to the same mobile service. So in my last session, I connected, 4 or 5 different versions of the application all to the same mobile service because it supports all of them. You want to use the same backend for all of those. Speaking of making those things, mobile services has support for a lot of different platforms. So obviously, we just saw on that Choose a Platform screen that you can choose Windows Store, Windows Phone, iOS, Android, and HTML, JavaScript. So those are kind of like the base where we have a quick start application as well as an SDK that supports those. So for Windows Store, or for Windows rather, we've got Windows Store and Windows Phone, and that actually works with a NuGet package. That's the Mobile Services SDK comes as part of a NuGet package, which also works on Windows Phone 7.x, as well as just pure Windows desktop applications and ASP.NET. So you can really use the same code to access mobile services from any of your .NET applications. As far as the HTML5 stuff goes and the ASP.NET, that means you kind of get cross-browser support for all these features that you get from mobile services. And then when it comes to doing Java, you got to look at Android or Google's Android and then Amazon apps as well. And then there's stuff like kind of cross-platform frameworks like Mono, where they have stuff like MonoTouch and MonoDroid, where you can write your C# applications, for iOS and for Android but you get to use C# and you don't have to learn Objective-C or Java. Well, there's a SDK that works for those, so you can connect to mobile services really easily from mono applications. And then with PhoneGap, where you basically take HTML and JavaScript and wrap it in a native application, you can take the HTML JavaScript SDK and just drop that right into PhoneGap and use it the same way. So there's tons of different platforms that you can use mobile services from. And anything that you can't, you'll be able to use a lot of mobile services, which I'll explain a little bit later. So a lot of the demos we show off are, hey, look at me, I'm pushing down to an Android application, or I'm pushing to Windows Store. I don't think I've actually seen a real presentation yet where it shows, here I'm pushing to Windows Store, and here I'm pushing to iOS, and here I'm pushing to Android. It's a lot to demonstrate. But there's important things you should consider when you're going to have an application that runs on several platforms. So here I have an example of the push code for each of the 4 major platforms we support. And this is kind of like their basic push code. Now, some of these have overrides. Like if you look at the push.wns, there's probably like 60 different methods because you can flip text and pictures and all sorts of stuff. So pushing can be complicated depending on what you want to do. The problem is you really need some way to track, if I'm pushing to devices, how do I do it? So what I would suggest is having something like a device info table in your mobile service that keeps track of each device connected to your application. And so what I've got here is I've got a column that contains like a device ID, which is just a random generated string from a device, what the actual push token is, so whether it's a channel URI, if it's Windows or Windows Phone, or a token for APNS, or a registration ID for Android, what the actual platform is, so that way in your code side, do I want to use push.apns or push.wns? And then the user ID, because I might want to push notifications down to all of my application, or all of the devices that I'm using. So that way I can just say, give me all the rows that have my user ID, and then I can push to each of those. And then you may want to actually do different things for pushing depending on the version of your application and the version of the operating system. If Windows 8.1 introduced some new options for push notifications, you might want to use those, but only if the person's running Windows 8.1. And then it's always nice to give the user the ability to actually turn push on and off. So here I've got an example of a script where it's going to pull out all the device info records for my user ID. It's going to then loop through those and make sure A, it's not a simulator, and A, I actually have a token. Then it's going to check the platform, and depending on whether it's iOS or Android, we'll use APNS or GCM. And adding Windows and Windows Phone to this is quite trivial. It's just a couple more if statements. One really important thing to remember is that the channel URIs, the tokens, the registration IDs, those can expire. And if they do and you continue to try to push to them, A, it's not going to go through, and B, those providers can become unhappy with you if you're doing a ton of pushes. So make sure you check the response for your push notifications to see if you get something that says it's expired. APNS is a little different from the other providers in that you don't get a response back right away saying, hey, this token's expired. So in the push notification area in the mobile services portal, you can actually specify, here's a script I want you to run to check with APNS every once in a while, and if it's expired, then you can basically remove it from your device info or invalidate it so you don't continue to try to push to something's invalid. There's also something called notification hubs, which is built to kind of basically enable you to really easily do broadcasts, so send millions of push notifications, as well as doing templated push and stuff like that. There's a lot of really cool stuff you can do with notification hubs. There's a session all about that tomorrow that talks about how to use it from the client side as well from the server side. So I would check that one out. Virtual tables. So when you create a table, it spins up a REST API that you can contact, and it also generates scripts which get executed. What you can do, though, is that you can basically use those tables just as an endpoint and not actually talk to SQL. So if you wanted to execute some server-side logic, but you don't actually want to use a table, that's fine. You just never call request.execute. Alternatively, there's a new feature we launched last week called Custom API. And Custom API basically makes it so you don't have to create these virtual tables. Instead, you create a method, or you create a script that's not tied to a table in any way, and you can access it from all these different HTTP methods. And you can still wrap it in the same sort of permissions that you can do with tables. So if you want to say, hey, you can post to this endpoint, only if you're an authenticated user, you can do that. All of the client SDKs have the code built into them now. I think it was released sometime within the past week for all of them. So they'll talk to the custom endpoints for you. So it's still going to handle sending over the user token or sending over the application key if you want to do so. Let's take a quick look at actually setting up a custom API right now. So I've got this Protips MS mobile service I've already created. So I'll just go into the API area. And I'll just create a new custom API, so I'll just name this my API. And down here, I've got that permission setting, and I can set different permissions for different operations, whatever I want to do. So I'll just leave that as the default, and I'll go ahead and check that. It's going a little slow today. All right, so it creates that. I still see all the permissions here, and once I click on this, I can actually get the script. Now, right now, by default, all it does is it accepts a post request, and it will respond with 200 and say hello world. If I wanted to add get, I could just copy and paste that and do get. So I could have different functionality depending on what sort of HTTP method they want to call into. I could put all this in here, and then again, it's exposed and really easily accessible from all the client SDKs. So talking to Azure Storage. So mobile services is built off of SQL database. It's very, very turnkey in the fact that you can use SQL database without really worrying about it. You specify a table name, but you don't create columns, you don't create schema, you don't worry about that stuff. SQL database, however, it's a SQL-based system, so there are different advantages and disadvantages for a SQL-based system as opposed to NoSQL, like table storage. In addition, SQL is not exactly perfect for storing large chunks of data like, say, blob storage is. You can actually talk to Azure Storage now. It's not doable. It's doable. It's not perfect, though, and by that I mean it's not turnkey like using the SQL databases. SQL, it's just there. You don't worry about it. Basically, to talk to storage, you use your scripts, and then you use the Azure module. So I've got a few script examples here, and I think that should be readable, hopefully. So essentially, all these scripts are going to be somewhat the same in how we get access, in our initial access into table or blob storage. So we have our account name and our account key, and that's the storage account name and account key. We then use the Azure module to get access to a table service using that data. And then if we want to read the tables, we basically call query tables on our table service. And that's going to return back JSON data for all of our tables that are in our storage account. When it comes to reading table rows, same basic part at the top, we get a table service. We then use Azure to create a table query. And in this one right here, I'm just saying, give me all the rows for the table specified by whatever that table name is in parameters.table. Now, I could do a more custom query if I was going off partition key or anything like that here as well. Then at the end, we query entities. Again, we get JSON data, which we hand back to our calling application. One thing I'll point out here is that all of these are based in table scripts right now. So you can see at the top because it's read, query, etc. I could just as easily put this into an actual custom API if I wanted to, but I've got another example of doing that later on, so I kind of wanted to show you doing a virtual table approach. Creating containers is kind of interesting because, well, we switched over to blob service, so not much different there. But containers can be public or private, and basically that means that if a container is private, I need to get a special URL to access the data inside it. If it's public, then I just need to have the URL of the blobs inside of it, and I can access it. So this is basically just looking at a parameter sent in and saying if it's public, create a public one using that public access level right there. Otherwise, just create a container, and by default, it'll be private. Reading and creating blobs is kind of interesting. So the part at the top is the exact same as the last one. But then the way blobs work is that, at least in this example rather, we're not actually writing to blob storage from the client app, or from the server-side script. Instead, we're talking to blob storage and saying, hey, I want to save some data to blob storage. Our script then creates a shared access signature URL, which we can hand back to our client, and then our client can securely write to blob storage. That way, we're not sending a ton of data up to mobile services, who then is going to send it over to our blob storage account, and we don't have to read it back via the same mechanism. So here, we're creating a shared access policy and saying, I want to be able to read and write to this blob, and then I'm going to expire in 5 minutes. Now, realistically, you might want to separate this out into one that does reading and one that does writing, so you're not using the same script for both. But for conciseness sake, I just left it together. You then generate that shared access signature right here using all the information there. You create this Ask query string, and you basically send that back to your application. Within that 5-minute window, your client application can actually post the data to blob storage, and it'll be written there. And then you can access that data. Again, if it's a public container, you'll just be able to access it via the URL. If it's private, we need to generate a new SaaS URL with read permission in order to access it. I've got a little demo here we can show you that will kind of makes use of table and blob storage via mobile services. All right. Kill that. So it's probably going to take a second to reload because I haven't really hit this. Oh no, it's actually quite quickly. All right, so first I go in here, and this is when I'm pulling out all my tables. And then if I go to this one, it's pulling out all my table rows. And currently I just have one table row, but we can see, I've got all the row key, the partition key information, so it's all there. If I click in, I can go edit stuff. I've locked down the partition key and the row key because I don't want to change those. Pretty easily go in and add items. And this demo right here, it's doing everything textually based, but you can actually send over, the entity type, so it's actually will, save it as an integer as opposed to just strings. Once we go into blob storage, so if I want to create a new container, again, you can specify whether it's public or private, and then just the name. If I go into a container here, like I've already got one, so I'll just go to this test one, and my blob is an adorable little kitten. Now, if this was a private blob, this wouldn't work. I couldn't just use the URL that's connected to this to access it, because, again, I need to have a SAS URL. So this method right here will re-hit that script I showed you, get a read script, and then it will load the blob using that read script. And if you wanted to add a blob, again, we just go in, we name the blob, we select whatever we want to save, and then we create that blob with SAS. So we get that SAS URL from our mobile service, and then we write the data out. So let's talk about some REST. So whenever you create a table in mobile services, it spins up a REST API. This is basically the format. So if you create the to-do item table in the to-do example, it's going to be whatever your mobile service name is, .azure-mobile.net/tables/to-do item. And depending on the HTTP method you're using and then kind of the URL suffix, that's going to indicate what operation it actually goes to. And if we don't have a client SDK for the operating or the platform you're developing on, you can use this REST API from anything that makes a web request. So you can still use mobile services from anything as long as you're able to make that HTTP request. It also uses dynamic schematization kind of behind the scenes, so that's what gives that turnkey-ness to the SQL database. So you don't have to generate all your data or your schema. Now, there are two really cool utilities that I love showing off because they actually make talking to the REST API really awesome, and that's Postman and RunScope. So let me shoot over here. So I've got this Protips mobile service, and it's got a to-do item, or it's got a my table. I haven't actually saved any data to it yet, but what I want to do is I'm actually going to talk to it using something called Postman. And Postman's kind of like a REST API tool where you can basically generate requests, send them over to a REST API, and then you can see the data coming back, in a relatively simple manner. So here I'm just going to change this to, let's see, what was my name? Protips MS. And I'll say, let's see, it was my table. So I can specify the header. So I'm going to say, yeah, I'm doing application. I'm going to do JSON. And then I want to get all the data, so let me do a get. So I'll send that over. And what I'll see back is that it's not going to work. It's going to say I'm unauthorized. And the reason it's saying I'm unauthorized is that when I created that table, I said the permissions were you have to have the application key. So if I go over to my mobile service, go to the dashboard and grab that, I can go back to Postman and say x-zumo-application. That's the name of the header that mobile services expects to see for the application key. I can paste that in, and I can send it. I'm not getting anything back because there's actually no data there. So what I can do instead is I'll post some data, and I'll just say, I'll just do a text com and call it my data. So I'll send that over. So now at the bottom here, we see that we got a response back, and it has the ID on it. If I go back to my mobile service and go to the data tab, I can go in here, and I'll see that data. And I added this in the script, so that's just something in the script we'll see a little bit later. Now, if I change this back to a get, and I send the request in the get, now I'm getting my data back. And I'm all using this just from this web-based tool. I think Fiddler is a Windows utility because it's the same functionality where you can send these requests. But if I don't want to actually develop the client to talk to one of my REST APIs, I can use this really, really easily and really quickly and kind of get the same effect. The next tool I want to show you is called RunScope. Basically what RunScope allows you to do is you can specify a URL, and RunScope will act like a proxy for you. So I'm going to go ahead and add a bucket, and we'll call this build. And it's a free utility, so Just throwing that out there. So I put in the URL of my mobile service, and I get this other URL back. And again, this is like a proxy URL that I can then put into my application. So I'll put it in here for now. Actually, I'll put it right here. And now I'm going to post the same thing through RunScope. So I got my data back. It looks like it went to my mobile service. I'm getting the information back. And if I go over here to RunScope, it says, oh, you've got a new request. So I'll go ahead and click on this. And I'll expand this, and I'll view the request. And we see, OK, it went to tables/mytable. Let's see, it has some headers. So it has that Zumo application header, has some other stuff. And then I can view the response, and there's the response of my data. Now, if I do the same thing for my mobile service client, which is just as easy as download or basically when you create your mobile service client, instead of using the URL of your mobile service, you just use that RunScope URL, you can use the same thing. So if you think you're sending data over to your mobile service, but things aren't working the way you think they are, it's really useful as a tool that you can see exactly what's going across the wire and then what's coming back. So sending emails. So this isn't really built into mobile services, but we have a couple partners, like one for sending emails, where basically you sign up for them in the Windows Azure store, and then you can use a module that they have basically built for us inside a mobile services script layer, and you can do a lot, additional functionality. So for sending emails, we partner with a company called SendGrid. And basically, once you've signed up for an account with them in the Windows Azure portal, you're able to then, inside your scripts, basically, like I said, send emails. So in this example right here, what I'm doing is, the idea is I've got a new user, they've registered an account with me, I've got their email address, I need to verify their email address. So I'm going to send an email to them with a link they can click on that has a unique ID, and then when they click on it, I can look up their account in their database and say, yep, that email address is valid. So at the top, I'm just using crypto to generate a random user ID, or a random hex string that I can send to the user. I create a new instance of SendGrid, and I pass in the username and password that SendGrid gives me. I'm then creating an email object with all the to, from, subject, and text. And inside here, I've got my HTML link to actually give them so they can click on that, and then that website would in turn look at that parameter and then go to the database and say, this person's valid. So we call SendGrid.send and send in the information, and then at the end we can log whether it was successful or not. So let's go ahead and take a quick look at how you actually sign up for SendGrid. So I'm hopping over to a different account because the account I was using before doesn't actually have access to sign up for stuff in the store. But basically, inside of the Windows Azure portal, you go down here to the add-ins area, and you go to New, and then we'll go to Store. And there's a ton of stuff in here. Some of these are specific to mobile services and have modules, and other stuff just kind of across-the-board stuff you can use from Windows Azure. So I'll go down to the bottom, and I'll find SendGrid. I'll go to the next. Now, a lot of these have free offerings. So, for example, SendGrid does 25,000 emails per month, and as well as giving you a bunch of analytics on it. So if I was developing a little app or I was just testing something, I could certainly get by on just their free level really quite easily. So I'll just put this on my subscription here, and I'll call this Build SendGrid. And I'll go next. Oh, I can also choose what region it's going to run in. So I want it to run in the same region as my mobile service, because that way it's not communicating for very far. Go next. It's going to talk to SendGrid and get back all the pricing information. Yes, free sounds perfect to me. I'll go ahead and purchase that. Now, I've already got one here that I set up earlier, but basically, once it takes a minute or so to get spun up. But basically, once it's here, I can go in here and I grab the connection info. And so this is where I've got that password and that username that I put inside my script. So right now, I could just drop in a script, and I could already be sending email using SendGrid. So the command line interface tools, if you haven't played with them before, they're awesome. There's a lot of stuff you can do from the command line interface, and it's all scriptable, and it's usable via Bash and PowerShell. So it doesn't matter if you're on Windows or OS 10 or Linux, you can still use the command line tools. So let's go ahead and look at some of the command line tools we've got. So here I'm just going to say Azure, because when you do that, we actually get a list of everything you can do with the command line tools, and there's quite a stuff outside of mobile services that you're able to get access to. So stuff like virtual machines, SQL databases, websites, a lot of really cool stuff. So if I do Azure Mobile, we get a list of just the stuff that's specific to Azure Mobile. And if we go up here at the top, we can see, okay, I can create mobile services, I can delete mobile services, I can list out them, I can get their details, I can pull down the logs if I want to. So you could actually set up something to kind of display like a live log as your mobile service is running if you wanted to. I can change the keys. I can get configuration and set configuration options. We can access the tables and change the permissions, as well as actually seeing the data that's in our mobile service. We can upload and delete scripts. We can change the scale of our mobile service, as well as creating scheduled jobs. So there's a lot of stuff you can do, and again, it's all scriptable. This kind of comes into play, I think, during one of the sessions that I have tomorrow, where they talk about different environments and pushing changes, because you can script kind of pushing changes from a test environment into a production environment using the CLI. Service filters and delegating handlers. So this is something that works on the client side, and the idea is that you're able to intercept requests and responses that you're making to and from mobile services. Now you might be thinking, hey, I'm developing the client side. Why do I need to intercept the request? I'm actually initiating the request. Which is a completely valid point, because you're making the request, so you don't necessarily need to intercept it. But if you want to do something for all the requests to your mobile service, this is a good place to do that. So here we've got an example of Objective-C code where I'm going to append a version and a build number to each request. So I'm creating the string that has the build and the version number. I'm then pulling out my URL that I was going to post the request or send the request to, and I'm basically adding that information in. Then I take my request and I basically modify it to use the newer URL, and I make that request. Here's a probably much cleaner .NET example. With .NET used basically delegation handlers, whereas in Objective-C and in Java, they're service filters. So with a delegating handler, when you create your mobile service client, you can specify an array or however many you want delegating handlers. So here I'm specifying that I have a version handler. And that basically means that whenever I make a request, it's going to call this version handler to kind of intercept that request. So then down here in my version handler send a sync method, I can change the request URI to be the URI I had and then add in the version and then just send that request. Now I don't have an example here of actually handling the response, but we are going to look at that a little bit later. Script versioning. So script versioning is something you probably won't think about until, well, chances are you won't think about until you've actually gone to production. And the issue is, what if you have version 1 of your application and version 2? And, you want to do some things that are specific to version 2. So, for example, like when I mentioned push notifications earlier. Maybe if they're running version 2 of your application, you want to send a push notification of one sort, but version 1, you want to do something else. So it's very useful to actually send that version information over whenever you make a request. So here's an example here where I've assumed that if they're running version 1 of my application, they don't have a property called description on the JSON object they sent over. So A, they're not going to send that over, so I don't have anything to save. And then B, when I reply back, like if I have a description item in my database, it's going to go back. So what I'm doing here is I'm checking the build version. I'm saying add a description column or field if it doesn't exist. And then once I've executed the insert in the database, remove that so I'm not sending it back. The client may be fine with getting data that it doesn't expect back, or that could cause a problem. This way I don't have to worry about it. I'm not going to send that data back. There's going to be some more talk about versioning tomorrow at a session on going live and beyond with mobile services, and that also will talk about doing different environments and stuff like that. So it'll be a good one to go to. So talking to Twitter, one of the great things about the mobile services scripting layer is that you can use that to do a lot of stuff. Like let's say I want to post to Twitter. So I think earlier this month Twitter retired version 1 of their API. Version 1 of their API was cool in that you could do some fun stuff with it without actually having to authenticate requests. With version 1.1, I think all the requests have to be authenticated. And authentication with Twitter is really painful. So I thought we'd walk by each line of this code and talk to you all, but no. This is basically the code I've got that would, with version 1.1, would do a post to Twitter. So it's just terrible. So instead what we've got now, thanks to some of the new stuff we've just recently launched, is we can do like a shared script. So in this case here, I've got a custom API where when I get a post, I'm going to pull down a Twitter JavaScript file that I created, which has an init method which takes in the consumer key and secret of my Twitter account or my Twitter application. And then it takes as a tweet method where I can pass in the text I want to tweet, the actual user that made the call, because I need to get that user's auth token and secret, and then the request because my tweet function will actually handle replying back to my calling application. So that script's available there, but there's also kind of an easier way to do it that I'll talk about in a minute. So let's talk about script source control. So this is a new feature that we launched last week. And essentially what you can do is you can enable this on the dashboard, and then that creates a Git repository. You can then clone that Git repository locally, and then you can make changes to your clients, changes to your scripts from your local box. So here's an example right here where I've created a Git repository, and I've pulled down the data. And so I've got all my APIs, my custom API scripts, as well as the permissions for those in a JSON file. I've also got a scheduling script called myJob. Then I've got a shared script folder, which I'll talk about in a minute. And then I've got my table scripts, which have the individual scripts as well as the permissions. So I can change all of these locally and then go ahead and push them out to the server. So let's go ahead and actually do that. So I'll go to this mobile service right here. And I've already actually set it up on the dashboard, but basically right here, there'd be a link that says, set this up for script source control. Once you've done that, if you go to the configure tab, it'll actually automatically redirect you there once it's set up. But you have this Git URL right here. So if I copy that Git URL, and I'll just make a new directory, and I'll go ahead and clone that. All right, here we go. Let's hope it works. All right, good. So now I can go in there, and the first thing we have a service folder, so this contains all the stuff inside of my service. If I list this out, so here we've got their API folder, the scheduler folder, the shared folder, and our table folder. Let's go ahead and go to the table folder, and I've got my table.insert.js. If I go up here to data and I go to my table, I go to script. All right, so we see that whenever I insert an item, I'm going to add something called new property onto that item, and I'm just going to insert the text something dark side. So I'm going to go ahead and change that locally. All right, so here's that same script. So we'll just add that. So we'll do it 3 times. So now if I check the Git status, so you change that. So I'll go ahead and add that, commit it, and push that up to the origin. And it's going to go ahead and push that up. It's going to redeploy it. It's done some other fun stuff. And now if I go back here and I refresh, we should see the script's been updated. After a moment. There we go. So really easy to make changes in my scripts and then push them out locally. So now I also have, a version history of my scripts as well that I can easily track. So shared scripts. I alluded to that shared script folder, and I kind of talked about it earlier when I showed you that Twitter module. So basically the idea is you put a script in there, and then all you have to do is require it from any of the scripts you want to access it from. Now, unfortunately today there's 2 minor issues. One is that you can really only pull them from your custom API scripts. We're working on fixing that, so within a couple weeks you should be able to also access the shared scripts from your table and your scheduled job scripts. The other issue is that if you push a change to a shared script right now, not a new script, but a change, it doesn't actually get redeployed until you make a configuration change. So basically what I mean by that is, if I go into shared scripts and I've got a script right now, and I make a change to that, push that out to the Git server, it's not going to take effect right away. Right? Today I've got to go back to my mobile service portal and make a configuration change. So the easiest way I do it is usually by turning on and off dynamic communization, which will trigger that redeploy. That's another bug that we should have fixed very soon, but if you guys are going to go home and play with shared scripts, I don't want you guys to say, hey, Chris, it's not working. What am I doing wrong? So again, that should be fixed pretty soon. But that also gives you the ability to kind of reuse a lot of your scripting logic without having to put it all in every single script. So next we're going to talk about some advanced authentication stuff. Now, mobile services has built-in support for authentication with Twitter, Microsoft, Google, and Facebook accounts. But you also have the ability to kind of do custom auth if you want to. And basically what I've got is some scripts here that I'll show you that will facilitate that. So the idea is from your client application, you pass in your username and password. You then do whatever validation you might want to do. So your password needs to be at least 5 characters. It can't be 1, 2, 3, 4. And then you create a salt, and you hash the password on the salt. And you save some of that information in the database. You don't save the password in the database because we never save passwords in the database. We then create what's called a JWT, or a JSON Web Token. And we hand that and the user ID back to the application. Now, when you do authentication with one of the built-in providers, mobile services is basically doing that for you. It's basically creating all that stuff and then creating a JW2 and handing that back to your application. And then your user gets your current user property or object in whatever client you're working with gets set with a user ID and a mobile service auth token. So basically, you just kind of create that stuff for your application if you do custom auth. So we won't walk through all this because it's somewhat complicated, and probably within a few days I'll create a custom module that you can just require, and then you don't have to worry about this at all. But essentially, we've got a message which will hash the password and the salt. We've got a method that does a slow equals, which is a security thing to kind of make sure our hashes are the same. And then we've got this method here which actually creates the JWT. Now, it's not necessarily important that you understand each line in this code because it works and you can more or less drop it into your application and call it a day. So when we actually use it, first thing we do is we're going to validate and make sure, is the username match whatever format I want it to be? Is the password long enough? Does the username not already exist? Once we've done that, we create a salt using the crypto library. We then hash the password using the salt. We set the password that we're going to save on the property to be whatever the hash is. So we're replacing whatever the clear text password they sent to me with, that hash. So again, we don't save the password locally or on the database. We insert that, and then after that, we remove the password and the salt from the JSON item before we return it to the user because we don't want to give that data back to them. We then generate a JWT, set that as a token, and give that back to the application. The application would then set its user ID and mobile service authentication token properties using that data. And then the next time they make a request, it'll automatically come across the wire, and mobile services will say, yes, this is a valid user ID and a valid token. The next part to that is actually when you want to sign in. So the user is signing in from a different application or whatnot. We need to check to make sure that the credentials they send in are valid. So we make sure that they actually have it, the username is actually real. We do that same hash again of the password they send up and that salt from the database that we saved, or the database record. We use that slow equals method to compare the two. And if it's good, we create a new JWT, which we hand back along with the user ID. Again, on the client, you set the properties locally, and then all your requests will contain it. And if not, you respond with 401. Now, there's also a partner in the Azure store called Auth0, and they facilitate some of the advanced authentication stuff that it's a little bit harder to do with mobile services right now. There's a session tomorrow on who's that user that will actually demo Auth0 since I don't quite have time for it today. But there's a lot of fun stuff you can do there, like integrate with other providers as well as AD and on-prem and Windows Azure AD. Now, the next step is obviously, my users all logged in. Every time they restart the application, I don't want them to have to log in again. So we're going to cache the identity. And this is relatively easy to do, and I've got an example of doing this. So in .NET, I'm using something called a credential locker to wrap access to the password vault. So here I've got a method to add the credentials. It's going to take in the username and password. And that username is actually going to be the user ID, and the password is actually going to be their authentication token. The idea being that we want to save this information locally, but we don't want to save it somewhere where it could be accessed nefariously by some other application, or really even pulled by the user. We want to hide it. So then we got a method to pull the credentials back out. And then if they sign out manually or something along those lines, we want to be able to remove those credentials. So then here we've got the code to actually use it. So first we call login async on our mobile service of the provider. So here we're doing Facebook. And then we add the credentials to the credential locker, and we pass in that user ID and that mobile service authentication token. Again, that's that JWT token that mobile service generates for me. And then at the bottom, whenever we launch the application, we can say, hey, do they have credentials? If so, set the user. Otherwise, ask them to log in. So if you do cache your user tokens and your user information, there's something you need to be able to handle, and that's expired tokens. And basically, those JWTs, they expire after some period of time. So the idea is that you make a request from your client application. You then check the response, and if it's a 401 response, you know that your token's expired. Or you know that something's making a bad request that doesn't have permission and shouldn't be doing that. But for the sake of this demo, let's say you should have permission. So you make the request, you get back, and it's a 401. You ask the user to log in again. Once they've logged in, you update the initial request with that user token. You can then resend the request, and then you should get back a proper, whatever response you were looking for, and you can go ahead and update your UI or continue on processing. So here's where we see the other side of delegation handlers and service filters, where we're actually intercepting the response back. So the first thing we do is we actually call, send async, and we await that response because we want to know what the response is. We check the response status code, and if it's unauthorized, we know that, the token's expired. So there we call login async again and have them log in, and we await that. Then we change the request x-jumo-auth header to be whatever the new token we got back is, and then we resend the request. Now, if they keep logging in incorrectly or if they cancel out of the authentication, you probably want to have something here that would dump them back to your home screen. But for the sake of clarity, we're just not checking for that right here. So in iOS, slightly more complicated. But again, we check the status code for a 401, and we ask them to log in again. Provided they log in successfully, we then change the x-jumo-off header, and then we retry the request. So we'll take a quick look at an application that does a lot of this for us. So here we've got an application that has all the different authentication providers that are built in, as well as the ability to do login with email. So I'm going to go ahead and register for an account. And let's say test user. I think I can do this as a password. Let's see. Test user. Don't tell anyone that's my password. I'll just use my email address there so I can get rid of that. Register. Oh no, is my service not going to work? Yeah, there we go. So it did work. It just took a second because the service hadn't been hit in a while. But so I'm logged in, and now I've got this custom. This is my user ID. So typically, if you log in with one of the other providers, it would be Twitter colon and then your user ID, or Facebook colon ID, or Microsoft, etc. When I do a custom, you actually specify your own user ID. So in this case, it's just custom, and this is the fifth user I've created. And now, basically, that token that I've got is basically my user ID signed with my master key. So that way, when I send this data back up to my mobile service will say, here's the user ID you're sending, here's the token. If I sign this user ID with the master key, do I get the same value? And that's basically how all the authentication works to make sure you are a valid user. And then in this application, I've also got some functionality to basically say, let's see, I think this will kick me out and tell me to log in again. Yeah, well, it died. But basically, this application has the same functionality where it'll force you to re-log in if you have a 401. Oh yeah, I don't think I have the functionality to re-log in if they did custom off. Anyhow, so we'll continue on. So one-to-many. Mobile service is not an ORM. It doesn't have any concept of sending up data and saying, this record has relationships to all this other data. It's something you can do manually, which I'll show you kind of how to do here. It's just you have to do it yourself right now. So there are two kind of ways to do this. We can do it on the client side, and we can do it on the server side. So on the client side, I've got an example, and I've got a big to-do item, and it has a list of little to-do items. And I've got the attribute ignore data member on that list. So basically, that says whenever I serialize or deserialize this big to-do item, it's going to ignore that list. So then when I actually go ahead to save the data, I first call insert on the big to-do item. And then provided with success, I can then loop through my little to-do items and call insert on each one. Now, that might be more than we really want to do on the client side, so we've got some server-side options. So here, the idea here is that we've already inserted our big to-do item, and then we call insert on the little to-do items. We pass in the whole array. So here we're going to loop through each one, and we're going to insert it, and then at the end we'll respond back with an array of the IDs, and then we can update those IDs locally on our client. Now another way we could do it is to actually send the whole block of data over as a JSON object. So the first thing we do is we pull that little to-do items list out, and then we remove it from the big to-do item. Because we don't want it to it's not going to know what to do if it tries to insert a list of data when it tries to insert our big to-do item. Then what we do is after we've actually successfully inserted our big to-do item, we can then loop through and insert each of the little ones and then add it back to our JSON item that we're going to respond to, and then send that back to our application. Now, one thing to consider when you look at doing something like this is that remember that now usage is based off API calls. So when I did that client side, I was making one API call for each of the clients, each of the little to-do items. So if I had 10 items inside my list, I'd make 11 calls there because I have to make one for the big to-do item and then one for each of the little ones. As opposed to on the server side where it was split between one method that would take 2 calls, one for the big and then one for the list of little to-do items, or just one call across the board. And then the other thing you have to factor in is that when you do the pull down of the data, it's the same kind of way. You can either do pull down the big to-do list and then pull down the big to-do item and then pull down a list of the little to-dos, or you can pull it down as one big object. Paging data is also something that can be done on the client and the server, and it's relatively easy both ways. So here you've got C# where we do that link type call, and we do .where, and we specify that the complete item is equal false. and then we say skip 3 and take 3. So wherever the complete item, the complete flag is equal to false, skip the first 3 and then take 3 records. In iOS, you do something with NS predicates. Now, predicate's kind of like basically creating a where clause. So here we're saying complete is equal to no, and then we create a query using that predicate, and then we can spec the fetch offset and fetch limit on the query. And those are terms that come from core data, which is kind of like a ORM with inside of iOS. And then Android uses a very method-based approach. So we say .where, .field, complete, .equals false, and then .skip and .top. Now on the server side, a couple different ways. So we can say, .where and add a query, and then we can call .take and .skip. We can get the query components and skip the take and skip properties, and then call set components. Or for the where clause, we can actually pass in kind of a function, which can be a little bit more advanced than this, but right now it's just doing that complete is equal to false. And then we can call .take and .skip on it. So as far as on-prem goes, because there's some interest in connecting mobile services to kind of on-prem resources, there's a few different options you've got. For data synchronization, you can use something called SQL Data Sync, and that will enable you to basically sync the database that's connected to your mobile service with the database that's on-premise, and you can send data back and forth through that service. We also have something called service bus relays, and you can kind of send information from your relay, from your mobile service into your relay, which your on-premise applications can access. Vice versa, you can send data from your on-premise application into that relay, and then your mobile service can access that. And it can do that using the Azure module I showed you earlier for accessing table and blob storage. There's also the Windows Azure Virtual Network, which you can use for kind of more advanced VPN stuff. So I've got a couple different kind of models or diagrams of using service bus relays. So in this instance right here, our application would talk to service bus, which could talk to a cloud worker, and then talk to SQL, which is the SQL that drives our mobile service database. The other example is where our mobile service could talk to a service bus, our on-premise app could talk there, and basically we can send information back and forth. Now, none of this stuff is exactly as turnkey as just using mobile services is. So it's not quite as simple as just turning something on. You kind of have to do a little bit of work there. As far as point-to-site VPNs, basically you can connect your remote devices in your mobile service and then talk to resources on the mobile service side to your on-premise resources. And then there's the site-to-site VPN, which actually connects your on-premise stuff to mobile services, or to Windows Azure. This is pretty complicated stuff, and I wanted to cover it at a high level, but I also wanted to point you in a direction where you can get more information. So there's 2 sessions from TechEd, which just happened a couple weeks ago. One about the hybrid networking, which is all about virtual private networks, and one about using Windows Azure websites with on-prem, which really talks a lot about that service bus relay stuff. Yes, that's websites, but a lot of that stuff really still applies since mobile services is built off of websites. So I've got some resources here for you. So you can sign up for a free trial account at windowsazure.com. There's tons of videos, tutorials, and other stuff at www.windowsazure.com/mobile. If you don't include the www, I believe it won't direct you correctly. Then I put together a page at aka.ms/commonwams, and that has a ton of resources. Basically, there's a lot of blog entries that kind of compile a lot of the stuff I talked about, like how to do custom identity, how to do different data like one-to-many. There's a lot of links that will talk to you about, in more detail about how to do each of those things. So really, really great resource. And it also has links to all the tutorials for mobile services kind of in a table format, so it's a little easier to get to. You can always contact me. There's my website and my Twitter handle. And then, my computer. And then day 2 of build is done shortly after. But tomorrow there's still 5 sessions that either directly have to do with mobile services or play into it. There's a Windows Phone app session in the morning, followed by Going Live and Beyond, and I mentioned that because it's about staging environments and versioning and a lot of really cool stuff for when you're going to go live. There's a session on the push notifications with Notification Hub, so delivering millions of push notifications. There's a session with more detail on user identity, including an example of using Auth0, so really cool demo there at 2. And then also at 2, there's a Windows 8.1 session. And I know Nick's going to touch on doing geolocation and stuff like that, so it's a pretty cool session to check out. So with that, I'd love if anybody had any questions. Thanks everybody for coming. I appreciate you fighting off the free beer that must have been somewhere else.